Okay, in this video, I'm going to introduce the idea of a binomial distribution. So again, big picture in this chapter, we're talking about discrete probability distributions, and the binomial is a special case of a discrete probability distribution. So it has its own formulas that are specific to its own distribution. So let's talk about it first. So the binomial distribution is used basically when you have two outcomes. So here are the properties of a binomial experiment. If you have a binomial experiment, you can use the binomial distribution. And then if you have a binomial experiment, you can use this probability function to calculate the probabilities, and then you can use these equations to calculate the mean and the variance and the standard deviation. So the first thing to do is to understand what a binomial experiment is, because if we know we have one, then we know we can use these formulas to calculate the probability function, the mean, and the variance, and then if we have those, then we can calculate probabilities for different events. So let's go through these. So first, the experiment consists of a sequence of n identical trials. So let's think about flipping a coin. So if we flip the coin 8 times, right, n would be 8, and those every time we flip the coin, that would be a trial. So the first thing is that the experiment has to consist of n identical trials. So each time you flip the coin, it's the same. The two outcomes are possible in each trial. We refer to one as a success and the other as a failure. So typically we'd say that, hey, if you flipped a coin and you got heads, that's success. If you got a tails, that's a failure. That's just common notation that we use. So again, there's two outcomes only for a binomial experiment. Right, that's the word bi, meaning two. The third property is the probability of success, right, maybe getting heads, is denoted by P. It does not change from trial to trial. So basically, you say 50-50 flipping a coin, right? It can't change to the next trial. So each trial has to have the same probabilities for success and failure. So then obviously failure is going to be 1 minus P, because, right, the sum of all the probabilities has to equal 1. So if the chance of getting heads is 50%, then 1 minus 50% is 50% for the tails. And then the trials are independent. So basically what that means is if I flip a heads on the first trial, then on the second one, it doesn't matter if I got a heads or a tails before. Each trial is independent from the one from other trials, basically. So like I said, that's important because if we have that, then we can use these formulas here to calculate basically the properties or the probabilities for the binomial distribution, these values that we can then use to calculate probabilities of events. So actually in the next video, I'm going to show you an example of where this formula comes from, right? This complicated looking formula. It's actually just based off of everything we've learned about so far in this chapter.